All right, welcome part two of the Z-score. So if you got this on the previous slide, fantastic. If you didn't, go ahead and calculate these various Z-scores right now. What is her Z-score for English, her Z-score for Mandarin, geography, and so forth? If you're real careful, you ought to get these values, assuming I was careful enough, which I think I was. Those are the values you should get. Now let's try one more example. Go ahead and pause it, give this one a shot. Okay, let's go over it. So again, this tells us how many standard deviations from the mean a score is. Again, how many standard deviations from the mean. So which tree is the most abnormal? We have a bunch of heights from trees from Wanaka. We have the means of that breed and species, I guess, and the standard deviation. So in calculating those z-scores, what we do to compare these is we just calculate those z-scores. I'm experiencing, you guys are the only people I get to talk to right now, really. So my mouth hasn't worked in a long time and it's hard to speak, but I'm working at it. Okay, so calculating all these z-scores for you. For the cotton tree was exactly, oh no, I made a mistake right here already. It was one standard deviation below the mean. I dropped my sign here. This was 44 minus 50 will be negative 6 divided by 6. So here this means it's negative 1 standard deviation from the mean. And next one, the cherry tree, the score minus the mean divided by the standard deviation, we get 1.5. Our score minus the mean divided by standard deviation, we get that. Score, I forgot my negative sign here again. Score minus mean divided by standard deviation, we mark that. And again, score minus standard deviation, we should get negative 2. So as far as which tree is the most abnormal, this hickory tree is the furthest from the mean. It's 2 entire standard deviations below the mean, which if we go all the way back to this all, 2 standard deviations below, that means it's in this section. That means it's among like the 2.5%. So itty bitty, that's very rare. Most of these we'd expect somewhere in here. Looking at this score, negative 1 right here, that means it's falling right here on this curve. Or similarly, 1.5 standard deviations above, that means 1 standard deviation here, so that's somewhere in this is the context of what that means. Okay, so that's this example. Onward. Another big thing to write down. This is the second huge thing I would write down for everyone. All right, so again, the z-score. This is a big idea. The number of standard deviations from the mean. And we've seen this now. This is the third version of this we've seen. Earlier, we saw x is distributed normally, or x is distributed on the binomial. What this does, this standardizes a data set. That's again why it's called the standard normal. And so what this is saying is this takes the place of the variable. Because we're putting in the variable scores here, z becomes the variable. We've just shifted it. We've shifted it horizontally and vertically. Again, a horizontal shift, a vertical shrink or stretch. That's what we've done. We've just transformed the function. So now z is our variable. And forever and always, this is a big idea. Z, whenever you see z always has a mean of 0 and always has a standard deviation of 1. You'll be given questions in which you just have the z-score. They won't give you the mean, they won't give you standard deviation, nothing else. But as soon as you see z, you can assume a normal distribution. So you can use like normal PDF in your calculator. You can assume a mean of 0 and a standard deviation of 1. These are all assumptions whenever you see z. Okay, I hope that made sense. As always, don't hesitate to shoot me an email, or I'd be happy to video chat on any of this. Again, I miss getting to interact with you guys in person. It's way more fun than just talking at my computer. Okay, to practice these, we're just doing the standard normal 1 through 5, and I'll show those two. Question 1, you've probably already done, or hopefully you've already done, so you can just take a picture of that. Question 2, you have not done. Go ahead and give this a shot. Again, it's really interesting to finally be able to compare different scores of different data sets to see how do they really stack up against each other. Here's slide 3. And slide 4. Again, I'm happy to give you guys hints on these. Just let me know if you would like them. Keep in mind some of these properties of Z and so forth. We can go over any of that as you guys wish. Okay, I hope everything's going well, and I will talk to you soon. Take care, guys.